In section 4.2, we're going to get some translations of the sine and cosine, meaning we're going to start moving the function. The first thing we're going to talk about is phase shift. That's a horizontal shift, moves to the left or the right. In the formula, y equals a sine b parentheses x minus d. In this argument that we have here, that's called the argument, x minus d. The d is the part that's going to tell you how you're going to shift. Now, when you are going to graph this, before you find the interval, you want to take the argument and place it in an inequality. So let's see how this is going to work for the hand graphing. So y equals negative cosine of 3x plus pi. So this 3x plus pi is the argument. We're going to put it inside the period. The period is, you could do this two different ways. And the first way that I'm going to show you is leaving this argument exactly as it is. The period is 2 pi in a basic cosine. So we put 0 on the left and 2 pi on the right, less than or equal to, and we put the argument in here. And we're going to solve for x. When we do that, we've got to get x by itself in the inside of that. So the first thing we'll do is subtract pi from here and here. So if I subtract pi everywhere, I'm left with 3x, I'm left with minus pi, and I'm left with pi because it was 2 pi minus pi. Then I've got to divide every piece by 3. So I have negative pi over 3, x, and pi over 3. So your basic interval in that chart that we're going to create goes from negative pi over 3 to pi over 3. And you'll find the other 3 parts. So on here, and I had somebody else writing this one day, so negative pi over 3 to pi over 3. What's halfway between those two is 0. What's halfway between negative 1/3 and 0 is negative 1/6. And between 0 and 1/3 is 1/6. So you have x, then you have 3x, then you have 3x plus pi, then you have cosine of 3x plus pi, and finally you multiply by negative 2. So 3 times negative 1/3 gives me negative pi. 3 times negative pi over 6 gives me negative pi over 2. 3 times 0 is 0. 3 times this gives me pi over 2, and this gives me pi. Then I'm going to add pi to that. So negative pi plus pi gives me 0. Negative pi over 2 plus pi gives me positive pi over 2. 0 plus pi is pi. 1/2 pi plus pi gives me 3 pi over 2. And pi plus pi gives me 2 pi. Ultimately, every time we do this, we're going to end up somewhere with these 5 that are very familiar. And when you take the cosine of this column, cosine of 0 is 1, cosine of pi over 2 is 0, then you get negative 1, you get 0, you get 1. These things will become very familiar to you. Then we multiply that column by negative 2. And so now this is our graphing, here and here. So if I come over here, when I'm at negative pi, oh goodness, I don't think that graph is, that's not graphed. I don't have that one graphed. So, but what we would see is that your, say over here is negative pi. Well, right here is negative pi over 3, the one negative 1/3. So you might be here and you'd be down at negative 2. And then at positive pi, at negative pi over 6, which would be here, you're at 0. So we're here. Then at 0, we're at 2. We're back up here. At pi over 6, we're here. And at pi over 3, we're at negative 2. So you could see, if we connect the dots, somewhat like that. And what that tells us is that we had a phase shift. We didn't start at 0. We started at negative pi over 3. So that's what a phase shift will do. All right, so we're going to come here. Same idea with this one. This was 3 cosine of x minus pi. And then we had a, I don't know where that plus 5 came from. If we put x minus pi in between 0 and 2 pi, and we add pi, we got 3 pi and we've got pi. So this is our first and our last intervals here, pi, 3 pi. Halfway between is 2 pi. Halfway between pi and 2 pi is 1.5 pi, which is 3 pi over 2. And halfway between 2 and 3 is 2.5, which is 5 pi over 2. Then you had x minus pi, so we take pi away, we end up with this column. Then we take the cosine like we've done. So again, these two columns, familiar, multiply by 3 and you get this. So now, if you have to graph online, there's a couple of things that I wanted you to see. So your question might look like this, and the first thing I would do would say to enlarge it. And when you do, you're going to get this little palette of icons. And this one is cosine, this one is sine. So basically choose one of those. In this one it was a sine. So choose the sine one and click in the origin. So you click there. When you click there, you're going to get another palette. It's going to be this. And you get to put in your amplitude, your period, your vertical shift, your phase shift. So in this one, excuse me, the amplitude is 3. So you would put in 3 here. The period is 2 pi over 1. So that's just 2 pi. The amplitude is 3. That's that number there. This -4 was the vertical shift. I think I said that wrong a minute ago. So amplitude is 3. The vertical shift is going to be -4. 2 pi there. The phase shift is going to be pi over 2 units to the left. And when you click in here, you would get a way to either change these numbers, and you can either type pi for pi. I don't know that you have the icon in there. If it were negative, you're going to have a negative vertical shift. So this is the Sine editing tool that will come up. So hopefully that will work for you. Let me know if you have trouble on that. But let's go to the problem set. All right, so number 1, the graph of y equals sine x plus pi over 2 is obtained by shifting the graph of sine x how many units to the right or left. All right, so this is the number of units, whatever this number is. If it is positive, you're going left. If it's negative, you're going right. That's not intuitive, but that's what we need to understand in the parentheses. So we would fill that in. Number 2, the graph of cosine x minus pi over 3. That's going pi over 3 units to the right. Number 3, the graph of y equals 11 cosine x is obtained by stretching the graph vertically by a factor of 11. That amplitude is 11. Number 4, the graph of y equals -9 cosine x is obtained by stretching the graph of y equals cosine x vertically by a factor of 9 and reflecting. When it's negative, it flips over the x-axis. All right. Number 5, graph one period of the function sine x minus pi over 2. So basic sine starts and goes through 0, 0. This one is shifted pi units to the right. So that's what we see in this one. You just have to think about what you're doing and find the graph that matches. Use transformations to graph this one. Y equals -3 plus sine x. So when you're adding or subtracting a number, you're either going down if it's negative, up if it's positive. So you graph the sine x, which goes through 0, 0, except you go down and you're going through -3. So it is this guy. Okay? It's like you had the regular sign and you picked it up and popped it down. Y equals 4 plus cosine x. So cosine x starts at, it doesn't go through the origin, it's going to go through 1, but this one should be popped up 4. So if you look here, 1, 2, 3, 4, 5, because it should, you know, cosine starts at 1 and goes down, but this one is up 4 units, so it would be at 5. Choose the appropriate description. 4 sine of 7x minus 5. What is the amplitude of that? The amplitude is 4. The period is 2 pi over 7. Okay. And the phase shift is -5. Okay, so here's something we need to think about. Before we start figuring out all of these things, I want you to factor out the 7. So in other words, we would have 4 sine 7 times, if you take 7 out of there, you're left with x, and then that would be -5/7. Okay, so still amplitude is 4. The period is 2 pi over 7. So there's that. And the phase shift is 5 over 7. Does that, hopefully that makes sense. So before we start figuring out phase shift and those things, you want to make sure you just have an x here. That will make it easier for you. Let's look at 9. 3 sine 5x minus 4. So that would be 3 sine 5x minus 4/5. So our amplitude is 3. Our period is 2 pi over 5. And our phase shift is 4/5. So we are here. All right, number 10. And figure out all the stuff about this thing. So the amplitude is 2. The period is 2 pi over 1 because the number in front of x is 1. There is no vertical translation. There's no number being added or subtracted. The phase shift is pi over 4 units to the left. So I think we answered all of that. Number 11. 3 cosine x over 3 plus pi over 3. All right, so here's what we want to do. Just like I said, we want this to be a plain old x. So I need to pull out 1/3. And then I have x plus, now if I have pi over 3 divided by 1/3, that's the same as multiplying by 3 over 1. So that'll be pi. All right, now we can figure out our stuff. So amplitude is 3, period is 2 pi over 1/3, flip, and you get 6 pi. No vertical translation. The phase shift is pi units to the left. So we need to make sure that this is a plain x in the start of that parentheses. Just remember that. All right. So for this one, 2 cosine pi over 5, x minus 1/2. So the x is fine. Amplitude is 2. The period is 2 pi over 5. Flip, and you end up with 10 because the pi's will cancel out. There is no vertical translation. Phase shift is 1/2. Okay. 13. Find the amplitude, period, all of our stuff. So we are going to factor out the 2. 3 minus cosine 2, parentheses, x minus, and if you take pi over 5 divided by 2 over 1, then you flip that, you're going to have times 1 over 2 equals pi over 10. That's where this guy came from. So amplitude is now 1, because in front of cosine there's a 1. What's the period? It's 2 pi over 2, which is pi. The vertical translation, we do have a positive number being added up here. So that's 3. The phase shift is pi over 10. Graph the following function. So you're going to do that, like I said, you're going to have a cosine. You'll pick the cosine tool, and the period is still 2 pi. The phase shift is pi over 10. And so this one is over a little bit, just 1/10 of a pi over. But that's, practice with that. This one, 3/2 sine 2 parentheses x plus pi over 6. So just think about it. You've got an amplitude of 1.5, so that's up there. You've got a period 2 pi over 2, so this is repeating at pi. So you would put your period in there. And the phase shift is pi over 6 to the left, so it's over this way a little bit. So I think those, let's see, do we have one more? Yeah, we have the big one. So practice those graphs. If you have trouble, let me know. All right, this one is a regression question in Trig. So if you've done regression in algebra, this shouldn't be too bad. But I am going to put with the lecture notes a page that I use in my algebra courses of how to do regression. And it talks about how to turn your calculator on to do regression, how to enter the data, and then to calculate the model of best fit. There's some other parts down here, but I'm not sure that you need those right now. But let's go back. So you'll have that sheet. So what you'll do is you'll put in all this data. This is day 1 through 30, and a fractional part of the moon that's illuminated during that day. So that's a lot of data to put in, sorry. But you do have to put in the days will go in L1 and the fractions will go in L2. And you'll put all of that data in, and then you'll do a zoom 9, and that regression sheet will tell you that. And you are looking for the picture that you'll get a bunch of dots, and you'll try to figure out what it looks like. Think B is what it looks like. And then we want to come up with an equation. So in the sheet, it does tell you to go to Stat and over to Calc, and then you'll be looking in this list down here for Sine. So when you choose that and you tell it to create, you will get this in your calculator. It's the function right here, and then it gives you the A value, B, C, D. And you're going to put in the 0.47, it says round to 100, sine, your B value is 0.22, x, plus 0.37, close parentheses, and then plus 0.51, that's your D value. When you go put this in y equals and hit graph, you will get this that's following your dots. So it's an interesting process. If you've done regression before, you'll be fine. But I will have this in the lecture notes, so you'll be able to see it as you're looking in the lecture notes of how to go about that. So hopefully you'll get through that problem as well.